Alright, hey Ed. So I'm going to explain my convolution reverb here. A lot of the theory and background and researchy things are in the paper. So I'm just going to kind of do a quick overview of this program and then give a demonstration. So first I have this impulse response from, I think Stanford was giving away some impulse responses. So it's from some stairwell there. And P is the number of partitions of my impulse response, so I just cut it into 2, and then the size of each impulse response is the length of the impulse response divided by the number of sections, obviously. So then I keep those in this little array here, and so each is going to be double the length of the partition, so it'll be half partition, and then the rest of the slice will be zeros, and since it's stereo, there'll be twice the number of partitions. So I do the actual slicing here, where I take L samples from the impulse response, and then zero pad it the rest of the way, so that these variables will be 2L, and then I from there get the DFT of each one, and store the left channel here and the right channel here, and then increment up. So I have all of the slices there. Here's where I get the actual impulse input signal. I get L samples, which is the same size as the partitions of the impulse response. So each input signal block is that size. I get it from this wave file, but it comes in real time. And then I have this overlap buffer here for the overlap save, which is what I'm using. So here's the actual processing loop. It gets the L samples from the file reader, concatenates the overlap, which starts out as 0 up here, size L, so that this impulse or this input block is size 2L. First part is the old samples, second part is the new samples, and then you set it to the new samples for the next iteration. And then I create the accumulation buffer here that will accumulate all of the frequency spectrums being added. And I get the DFT of the input block, size L2 or 2L, and then I multiply that DFT with each of the slices that I partitioned earlier before the processing loop. I do it in stereo, so there's the left channel here and the right channel, and then I just accumulate, and I get a one-time IDFT of each channel, and then I take only the last L samples. MATLAB is weird. It's indexed. The first index is not 0, it's 1, which is really annoying. So L plus 1 to the end, and then this skunk here is just doing a wet dry so that you hear some of the input signal with it. So without further ado, I'll play what happens if it just bypasses all this and just outputs the input, so you know what it sounds like without the reverb. Gonna play it. Alright, and I will play with all of the convolution processing. Cool, so like I said, there's more background in the paper, but this is just showing that the algorithm works. It can be done better, but I'm feeling good about where it's at. So thanks for watching, and have a good summer.